video is about the domain of a function, and specifically restricted domains we're going to focus on. So remember that domain is the x values in a function. So graphically, I'm looking from left to right. And then algebraically, we're looking at a few different rules which we're going to go through. So when finding the domain of a function, you're going to ask yourself what values can't be used. The domain is everything aside from what can't be used. So there are a few rules to consider. First of all, the domain of all polynomial functions is all real numbers. For in interval notation, it would be written as negative infinity to positive infinity. You may also see it written like that. That's a symbol that means all real numbers. And let's talk just quickly about a polynomial function. So a polynomial function is something like x to the fifth or x to the third. It's any equation where the variable is the base and the exponent is a positive integer. So x to the first, x to the second, x to the third, x to the fourth, and so on. Those are all considered polynomial functions, and they all have a domain that is all real numbers. Think about a linear function. A linear function is just a line that goes on forever, infinitely in either direction. A quadratic is a parabola, goes on in either direction. If we're talking about a cubic or a quintic, something like that, goes on in either direction. So that's polynomial functions. Now, square root functions cannot contain a negative under the radical, because if I have a negative under the radical, it's imaginary numbers, and I can't graph that. So in order to, this is your rule number 1 for restricted domains. You're going to set the expression under the radical greater than or equal to 0 and solve for the variable. So for example, if we had f of x equals the square root of x plus 5, I would take what's underneath the radical, x plus 5, set it greater than or equal to 0, and solve. So my domain would be x is greater than or equal to negative 5. Rule number 2 has to do with rational functions. So rational functions, just a side note, is something like 1 over x. And rational functions cannot have 0 in the denominator because it makes my denominator, or my entire fraction rather, undefined. So rule number 2 is going to be to determine which values of the input cause the denominator to equal 0, and our domain is going to be everything else. So here's another example for you. If I have g of x equals 1 over x minus 3, my domain is going to be x cannot equal 3. It's the set of all real numbers except x equals 3. And then your third rule is kind of when you put these two together, which we'll look at in the examples. So we're going to find the domain of each of the following functions. Number 1, g of t equals the square root of 2 minus 3t. Remember, underneath the radical can't be negative. So 2 minus 3t has to be greater than or equal to 0. So we're going to just solve here. Remember that when you divide by a negative, your inequality symbol switches. So my domain is going to be t in this case, because that's my input, is less than or equal to 2/3. Or in interval notation, it would look like that. And remember, you could look at these on your calculator. If this was a calculator portion, or if you were just studying, you could always check it out there. So I am going to actually show you what that would look like here. So in my y equals, I have the square root of 2 minus 3x. If I hit the graph button, here is what this graph looks like, which relates perfectly to our domain. It is going infinitely in this direction, which is where my negative infinity comes from. And this value over here is the 2/3. Number 2, f of x equals x cubed minus 6x squared plus 5x minus 11. This is a cubic, which is a polynomial function. So all real numbers. Or if you wanted to write it in interval notation. Number 3, h of p equals p minus 1 over p squared minus 4. So this is a rational function. I'm worried about my domain in the denominator. So my denominator cannot equal 0. So this becomes p minus 2, p plus 2. You could always, of course, extract the square if you preferred. So my domain is going to be all real numbers, except it cannot equal plus or minus 2. Number 4, g of x equals 5 over radical x minus 7. So now this is where those two rules come together. My radical, if it was just this, I would set this up. X minus 7 has to be greater than or equal to 0, because for radicals, I can't have a negative. My denominator can't be equal to 0. So this is not allowed because we're in the denominator. So that means when it's a radical in the denominator, it's just going to be the expression greater than 0. You're going to leave out that equals because it's in the denominator, and it would make it undefined. So my domain here is going to be x is greater than 7. And once again, here's another one. We'll just check this one out so you can see what this looks like. It was 5 over radical x minus 7. So looks something like that if you wanted to zoom out, of course, but it's going to be greater than 7. It's never going to go to the left of 7. And if you wanted to put this in interval notation, it would be 7 to infinity. Notice how I have a parentheses here, not a bracket, because it does not equal. Looking at our last two, negative 4x squared minus 7x minus 3. This is a quadratic, which is a polynomial. So my domain is all real numbers. And lastly, number 6, g of x equals radical x over x minus 5. So I actually have two things happening here that I need to worry about. My part under the radical has to be greater than or equal to 0. And then my part in the denominator tells me that it cannot equal 5 because it would make it undefined. So I have all real numbers greater than or equal to 0 except 5. So you could put these together like this, but more than likely what you will see is interval notation with it written like this. Now, similar to number 4, I have a parentheses here and here because it can't equal that. But I'm allowed to equal the 0, which is why the 0 has the bracket. So when it can equal, it has a bracket. When it can't equal, it has a parentheses. So those are some examples of your restricted domains.